Hey everyone, and welcome back. We're diving deep into the world of graphs today,
Oh, yeah.
and specifically two algorithms that are key to understanding them: depth-first search and breadth-first search.
You probably know them as DFS and BFS.
Right, DFS and BFS.
And while those sound super technical, you actually use these algorithms every day without even realizing it.
Really?
Yeah. Just think about how you find information online or connect with friends on social media.
Hmm.
DFS and BFS are secretly working behind the scenes.
So we're talking about algorithms that power how we navigate, like, our digital lives.
Absolutely.
That's pretty huge. But before we get into all that, can you give us some background? Like, where did these algorithms even come from?
For sure. So both DFS and BFS have their roots in mathematics,
Okay.
going all the way back to the 19th and 20th centuries.
Wow.
They actually started as solutions to problems like navigating mazes.
So from solving mazes to, like, powering the internet.
It's quite a journey.
That's wild. So where should we start?
Well, one of the key figures in the development of BFS was Edsger W. Dijkstra,
Okay.
a Dutch computer scientist. Back in 1959,
Wow. 59.
he developed an algorithm for finding the shortest path in a graph. And that basically laid the foundation for what we know as breadth-first search today.
So this was even before the internet.
Yeah,
It's amazing how these early innovations paved the way for so much of what we just take for granted today.
it really is. Think about how GPS navigation works. Finding the quickest route from point A to point B.
Yeah.
Or even something as simple as finding the cheapest airline ticket online.
Uh-huh.
These are all rooted in Dijkstra's work.
Wow. Okay, so BFS has this incredible history, and it's all about finding the most efficient path. But what about DFS?
Right.
How does that fit into all of this?
So DFS actually takes a different approach.
Okay.
Instead of systematically exploring all possible paths like BFS,
Right.
it dives deep into one path until it reaches the end or hits a dead end.
So if BFS is like methodically checking every street in a neighborhood,
Yeah.
DFS is like exploring one street to its very end before turning back.
That's a great way to put it. And this deep dive approach is what makes DFS so effective in certain situations.
Like what? Can you give us an example?
Sure. Imagine you're using social media and you want to find out if you have any mutual friends with someone you just met.
Yeah.
DFS is perfect for this because it can trace a path through that network of connections, following one friend to the next until it either finds a connection to that person or reaches a dead end.
So DFS is the algorithm behind those people you may know, suggestions on social media.
Exactly.
That makes so much sense now.
It's all about exploring connections, and DFS is really good at finding those hidden paths in a network.
Okay, so we've got BFS, which is about finding the shortest path, and DFS, which is about exploring deep connections.
Right.
Can we dig into how these actually work, like the mechanics of the algorithms?
Absolutely.
Okay.
Let's start with DFS.
Okay.
One key concept to understand here is the idea of last in, first out. It's like a stack of plates. You can only add or remove plates from the top.
Okay.
So in DFS, as you explore a path, you keep track of the nodes you've visited in a stack.
So if you hit a dead end, you can just pop the last node off the stack and backtrack to the previous one, like taking a plate off the top of the stack?
Exactly. And this last in, first out mechanism is actually achieved through something called recursion,
Recursion.
which is a way for a function to call itself. It's kind of like a set of Russian nesting dolls,
Okay.
where each doll contains a smaller version of itself.
Okay, recursion sounds a bit complicated, but I think I get the gist.
Yeah.
Now, what about BFS? How does that work differently?
Well, BFS, on the other hand, uses a first in, first out approach.
Okay.
It's like a line at a store where the first person in line gets served first.
Gotcha.
And we use a data structure called a queue to manage this.
Okay.
So imagine you're trying to find the shortest path to a destination.
Uh-huh.
BFS would start at your current location, explore all the immediate neighbors, add them to a queue. Then it would process the queue one by one,
Okay.
exploring the neighbors of each of those locations and adding them to the queue and so on.
So BFS is like spreading out in concentric circles,
Yeah.
exploring each layer before moving on to the next.
Exactly. And that's why it's called breadth first search.
Okay.
It prioritizes breadth over depth, exploring all possible paths at a certain distance before moving on to paths that are farther away.
That makes sense. So we've got these two algorithms, DFS and BFS, with their distinct ways of exploring graphs. One
Sure.
diving deep, the other spreading out systematically.
Right.
But where does it all lead? How does any of this impact the real world?
That's a great question.
I'm guessing this is where things get really interesting.
You bet. And the range of applications is truly mind-boggling.
Okay.
Everything from social networks and search engines to artificial intelligence and even scientific research relies on these algorithms.
Wow, so these seemingly simple concepts are actually powering some of the most complex technologies we use every day.
Absolutely.
Yeah.
And that's exactly what we'll be exploring next.
Last time we left off with this idea that DFS and BFS are not just lines of code, but powerful tools that shape our digital world.
They really are.
What are some examples of these algorithms at work?
Well, think about how you find information online.
Yeah.
When you type a query into a search engine like Google,
Uh-huh.
you're essentially unleashing a modified BFS algorithm.
Really? I had no idea BFS was involved in something as massive as like searching the entire internet.
It is. Google's search engine uses a sophisticated version of BFS to crawl the web,
Wow.
following links from page to page,
Okay.
creating this vast index of websites.
So it's like a digital explorer,
Yeah,
mapping out the intricate pathways of the internet.
it really is.
So BFS is how Google finds all those websites and figures out which ones are most relevant to my search.
That's right.
That's incredible.
Yeah.
Are there other surprising places where we might encounter these algorithms?
Absolutely.
Yeah.
Let's talk about social networks. Have you ever wondered how platforms like Facebook calculate those degrees of separation or suggest friends you might know?
Yeah, I've always been curious about that. It seems like magic sometimes.
Well, it's not magic.
Okay.
It's BFS. Facebook uses a modified version of BFS to analyze the billions of connections between users, finding the shortest paths between them.
Okay.
This allows them to figure out who you're most closely connected to
Yeah.
and suggest potential friends based on your existing network.
So BFS is how Facebook helps us stay connected with friends and discover new ones.
Exactly.
It's amazing to see how this one algorithm has such a huge impact on our social lives.
It really does. But the applications of DFS and BFS actually go far beyond just the digital realm.
Oh, really?
They're also used in cutting-edge scientific research,
Wow.
helping us tackle some of the biggest challenges in fields like biology and medicine.
That's fascinating. Can you give us an example?
Absolutely. One area where DFS has proven to be incredibly valuable is in protein folding prediction.
Protein folding.
Proteins are these complex molecules that perform all sorts of essential functions in our bodies.
Right, like building tissues, transporting oxygen,
Yeah.
fighting off infections.
Exactly. And the way a protein folds into a specific 3D shape determines its function.
Okay.
But predicting this final shape from its amino acid sequence is a really challenging problem. It's kind of like trying to solve a giant 3D puzzle.
So how does DFS help with that?
Well, researchers use modified DFS algorithms to explore the vast space of possible protein conformations. It's like navigating a maze of different folding pathways,
Oh,
searching for the one that leads to the most stable and energetically favorable structure.
so DFS helps scientists find the right way for a protein to fold,
Yes.
which is crucial for understanding how it works and potentially developing new drugs or therapies.
That's exactly right. And one of the most impressive examples of this is DeepMind's AlphaFold 2,
AlphaFold.
an AI system that uses a DFS-based approach to predict protein structures with remarkable accuracy.
I've heard of AlphaFold. Wasn't it a major breakthrough in the field of biology?
It was. AlphaFold's success is a testament to the power of computational approaches, particularly those rooted in fundamental search algorithms like DFS to solve complex scientific problems.
It's incredible to think that an algorithm originally designed for navigating graphs can be applied to something as intricate as protein folding. What other scientific frontiers are DFS and BFS helping us explore?
Well, another fascinating application is in artificial intelligence,
AI.
particularly in game AI. You know how in video games,
Yeah.
the computer-controlled opponents can seem incredibly smart and strategic.
Yeah. I've always wondered how those game AIs work.
Well, DFS and BFS play a crucial role in creating intelligent game-playing agents.
Really?
Think of a game like chess.
Okay.
The AI's task is to figure out the best move to make at any given point in the game.
Right, but with so many possible moves, how does it even begin to make that decision?
That's where DFS and BFS come in.
Okay.
The game board is essentially a graph, with each node representing a possible board state, and the edges representing legal moves.
Okay.
The AI uses these algorithms to explore this vast graph, searching for the most advantageous path to victory.
So the AI is using DFS and BFS to simulate all the possible scenarios of the game, looking for the best moves.
Yeah.
That's wild.
It is. And of course, real-world game AI is incredibly complex,
Right.
involving a combination of techniques,
Okay.
including minimax,
Max.
alpha-beta pruning,
Okay.
and heuristic evaluations.
Okay, those sound pretty technical. Can you break them down for us?
Sure, minimax is an algorithm that assumes your opponent is always going to make the best possible move,
Okay.
and it tries to minimize your maximum possible loss.
Mm.
Alpha-beta pruning helps make the search more efficient
Okay.
by eliminating branches of the search tree that are definitely worse than other options.
So it's like a strategic shortcut for the AI.
Exactly. And then there are heuristics, which are essentially rules of thumb based on expert knowledge of the game.
Gotcha.
For example, in chess, a heuristic might favor controlling the center of the board or protecting your king.
So these heuristics help guide the AI toward more strategic moves.
Yes.
Making it feel more intelligent.
Exactly. And the amazing thing is that these AI systems,
Yeah.
built upon algorithms like DFS and BFS, can now compete with and even beat the best human players in some of the most challenging games.
It's mind-blowing to think that these seemingly simple algorithms originally designed for exploring graphs are at the heart of such sophisticated AI. It makes you wonder, what else can we accomplish with them?
That's a great question, and it leads us to an even more fascinating idea.
Okay.
The way DFS and BFS can help us solve everyday problems and make better decisions in our own lives.
So we've been talking about how DFS and BFS are powering everything from search engines to game AI and even scientific discoveries.
That's pretty amazing.
Yeah, it's incredible to see the impact of these algorithms.
Right.
But can we actually use them to improve our own decision-making
Oh, absolutely.
in everyday life?
Yeah. While we may not consciously think in terms of algorithms,
Right.
the underlying principles of DFS and BFS can be super helpful in approaching problems and making choices.
Okay, I'm intrigued. How so?
Well, think about planning a trip.
Okay.
You have a starting point, a destination, and a whole bunch of decisions to make along the way.
Yeah.
Flights, hotels, activities, all within a certain budget.
It definitely feels overwhelming sometimes with so many options.
Right. But you can actually apply a BFS-like approach to this problem.
Oh.
Imagine mapping out all the possible routes and combinations, exploring each step systematically to find the best itinerary that fits your constraints.
So instead of like randomly browsing flights and hotels,
Yeah,
I could use a more structured approach like BFS
exactly.
to explore all the possibilities within my budget.
Yes.
That makes a lot of sense.
And you can even incorporate heuristics,
Heuristic.
like prioritizing direct flights or hotels with good reviews
Okay.
to guide your search toward the best options.
It's like having a built-in travel agent in my brain.
Exactly.
Are there other everyday scenarios where DFS or BFS thinking can be helpful?
Absolutely.
Yeah.
Think about learning a new skill or subject.
Okay.
Some people prefer a DFS approach,
Okay.
diving deep into one specific area that interests them, following tangents and exploring in detail before moving on.
That's definitely how I learn.
Yeah.
But yeah, I get fascinated by one thing and I just want to go deeper and deeper until I feel like I've really mastered it.
Right? And that's a perfectly valid approach.
Uh-huh.
But others might prefer a BFS style of learning,
Okay.
getting a broad overview of the subject first,
Right.
exploring different areas at a high level before deciding where to focus their attention.
So it's like the difference between reading one book cover to cover versus skimming several books
Yeah.
to get a taste of different topics.
That's a great analogy.
Wow.
And neither approach is inherently better than the other. It really depends on your learning style and the specific goal you're trying to achieve.
This is making me realize that I probably use both DFS and BFS thinking without even realizing it.
Yeah.
Depending on the situation.
Exactly. And that's the beauty of it.
Yeah.
By understanding these different approaches, we can become more conscious of our own thinking patterns and choose the best strategy for each problem we face.
So it's not about always using one algorithm over the other,
Right.
but about recognizing when each one is most effective and adapting our thinking accordingly.
Precisely. And the more we practice thinking in these ways, the better we become at navigating complexity, making decisions, and even generating creative ideas.
This has been such an eye-opening deep dive. We've gone from the origins of DFS and BFS to their wide-ranging applications in technology and science.
Yeah, it's been great.
And now we're seeing how these seemingly technical concepts can actually help us in our everyday lives.
Absolutely.
It really highlights the power of algorithms not just as instructions for computers, but as frameworks for understanding the world around us and even improving our own thinking.
I agree.
As we wrap up this deep dive, is there anything else you'd like to leave our listeners with?
I think the most important takeaway is that in a world that's increasingly complex and interconnected.
Yeah.
The ability to think like a DFS or BFS algorithm is so valuable. It allows us to break down problems, explore possibilities, and make more informed decisions, whether we're planning a trip, learning a new skill, or simply navigating the digital landscape.
It's about recognizing the power of these mental models and consciously applying them to become more effective thinkers and problem solvers.
Exactly.
So the next time you're faced with a challenging problem or decision, remember DFS and BFS. Think about how you might explore the possibilities, what paths you might take, and what strategies you might use to find the best solution.
I love that.
And who knows, you might even surprise yourself with the creative solutions you come up with. Thanks for joining us on this deep dive into the world of DFS and BFS.
It's been fun.
Until next time, happy exploring.